Hello, everyone, and welcome to another episode of Dome to Home Perseverance to Mars. As always, my name is Jeremy. Above me, we've got Tara. How's it going?
Hello. Good. Thanks for joining us, everybody. And thanks for joining us for our last Dome to Home of the semester or of the series or whatever you want to call it. This is our last one for this round. So we're super excited that you came to join us today. Hopefully you've been able to attend some of the other ones too. If not, they're still on YouTube and you can go back and watch those too. Just a couple of reminders. If you're ever having trouble seeing any of the visuals, like this cool picture of Mars that Jeremy just put up, if you make your screen full screen on the YouTube, that sometimes helps. And we also have our friend Raimi here that's monitoring our chat window. So if you have any questions at any point that you want to ask, go ahead and drop those in the chat. She'll be keeping track of that. We'll try to answer some as we go, but we'll have time at the end, as always, for questions too. So we'll try to get to everybody's. And I think we're going to have a lot of cool questions, and I got a lot of cool ideas for you today, because we are talking about not the past of Mars and not the current state of Mars and rovers, but we're talking about the future and putting people onto Mars, people on the red planet, and what we have to do and some of the things that it's going to take to get to that point. So this is going to be a super fun one today. You got to put on your creative hats because we got to think way outside the box for some of this stuff. So one of the things that obviously we have to think about when we're talking about putting people onto Mars is, what is Mars like? So if you've seen any of our videos so far, you probably have a good idea of what it's like on Mars. But if you haven't, we can tell you really quickly a couple things that we know about Mars. A, it's very cold. Temperatures are like negative 80 degrees on average. So very, very cold, way colder than even Antarctica. We also know that Mars's atmosphere is not very friendly for people. It's very, very thin, first off, part of why it's so cold. And it's mostly made up of carbon dioxide, which is not the stuff we like to breathe. So it's not a very good atmosphere for people. We also know that Mars's soil, all this red dirt that you see behind me and Jeremy there, it doesn't have any nutrients in it. It's more like sand than the soil that we have here on Earth. So it'd be really hard to grow things like plants or food or anything like that. There's even some chemicals in the Martian soil that are toxic. So we don't want any of that. So Mars in general is not a really friendly place for people to want to live or work or anything like that. A lot of things would have to be done to Mars to make it a livable place for people, for humans like us. Now, the first idea that we have for putting people on Mars is, well, why don't we just build some little habitats for them? You know, just like people here on Earth live in inhospitable places. There's people that live and work in Antarctica or out in the deserts or in the rainforests. Not great places for people. So what do? Build houses, build shelters, things like that. So that's our first idea of how to put people onto Mars for long periods of time, is give them a place to live. Now, there's all sorts of really cool ideas about how we could build these habitats, what they might look like. And having a habitat really lets us control our immediate environment. We could make it warmer. We can give it nice oxygenated air. We could put all sorts of nice dirt and stuff in there for growing our plants and our food. Now, these are all really funny looking, maybe you think, I think. But a lot of these, the reason that they're so oddly shaped and weird looking is because our idea is to 3D print them. These aren't going to be things that we show up on Mars with a bunch of, sawed logs and things and hammer together. These are things we're going to ideally use stuff that we can find on Mars to build our habitats. So they found on the moon already that we can use the soil that's already there in a 3D printer with a bonding agent like a glue. And we can build little habitats, 3D print houses for us. So the idea is to send robots ahead of time to 3D print these little habitats, build them all up for us so that when people arrive, they've got pre-built houses already. One of the reasons this is so important is because for us to take all the materials up to Mars to build a habitat like the one you see here, it would cost, they said, about $2 million per brick to build a habitat on Mars.
Not cheap.
No, Not at all. And that's not just for the bricks. That's for like the rocket fuel that it would take to get there, to develop the technology to make these bricks in the first place that would last on Mars. There's all sorts of things you have to think about. If you saw our channel, our video on rocket launches and how complicated that is, we talk a lot about that there. So what if we don't want to build habitats? What if we want to think about changing Mars on a global scale? This is a very popular idea. It's a very interesting one. You may have heard the word terraforming before. This is something that people put forward to change the entire planet of Mars to make it more like Earth. Terra is another word for Earth, so this is terraforming, to form a planet that's more Earth-like. Now, I want to talk about some of the really cool ideas, some of the more feasible ideas, but also why this is such a difficult and complicated thing to think about. So let's think again about all the things that are wrong with Mars that make it difficult for us to live there. Well, what did we talk about? The atmosphere is unpleasant, right? We've got all that carbon dioxide. Well, what if we could fix the atmosphere? That's one idea, is to help fix the air. There's a process called 𝐀𝐜𝐭𝐢𝐯𝐢𝐭𝐬. I practiced saying that. That's a big word. And this is where they put these little colonies of bacteria in little domes like the one that you see here. These bacteria eat the carbon dioxide and produce oxygen, really similar to plants and bacteria and algae here on Earth. It was the same kind of process. Now, this is a really cool idea because not only does it get rid of the carbon dioxide, it produces the oxygen that we can breathe. The only problem with 𝐀𝐜𝐭𝐢𝐯𝐢𝐭𝐢𝐸, is, like you can see here, it has to be, these bacteria have to grow in this little dome. And so it's not something that you could do to an entire planet. You could do small areas, very small areas, maybe the inside of a habitat. That would be great. But it wouldn't be enough to change the entire atmosphere of Mars. So it's a good idea for small spaces, but not so much for big ones. Now, another thing that we don't like about Mars as human beings is that it's really cold. Like we said, negative 80 degrees in most places. That's really cold. Not good for people. So how could we go about raising the temperature of Mars as a whole? That's a difficult question. Well, one of the things that we've been able to do is look at what makes other planets really warm. Let's say, I don't know if we talked about Venus before. Venus is very, very, very hot. It's the hottest place in the entire solar system because it has a ton of greenhouse gases in its atmosphere. I'm sure some of y'all have heard about greenhouse gases here on Earth, things like carbon dioxide and methane. These are all things that we've talked about before that are in the atmosphere and help keep the heat in. What if we could just import a bunch of greenhouse gases to Mars? Would that help heat the planet? It's an idea. One problem with this, though, is that most greenhouse gases, they're all these really big molecules, but they don't weigh very much. They're all very light, all of these greenhouse molecules. And the problem with Mars's atmosphere is that it's constantly being blown away by solar wind. These particles from the sun are shooting out and hitting Mars and stripping away its atmosphere, just like this you see here. So if we put a whole bunch of really light atoms and molecules up into the air, they're just going to get blown away again. So that's not very helpful. Now, the other problem with this, and the one that I think is a bit more interesting, is that the most efficient way to add a ton of greenhouse gases to Mars would be to find big asteroids that are made out of a lot of these chemicals and slam them into Mars. Because what could possibly go wrong? How is this a really great idea? Let's just bomb Mars with a bunch of asteroids. I'm not sure that's the best idea of how to make a place livable.
Yeah, that might have some repercussions. I don't know.
Yeah, maybe a couple. So another idea of how to get some greenhouse gases into Mars's atmosphere was to add extra CO2, carbon dioxide, by melting Mars's ice caps. We've talked about before, the ice caps on Mars are made mostly of carbon dioxide ice. Well, carbon dioxide is a super powerful greenhouse gas. If we can put a bunch of that into the air, would that help? Well, maybe. On one hand, it wouldn't add quite enough carbon dioxide to really raise the temperatures. Even if we melted all of the ice caps and put all of that carbon dioxide into the atmosphere, it would only raise the temperature on the planet by about 1 degree. So I don't know if -80 to -79 is much of an improvement. It's a start, we could say. And so there's not really a good way for us to get there to melt all of this ice. One popular theory, some of you may have heard, it's been put forward by a very popular gentleman, is to drop nuclear bombs on the poles of Mars, and that would melt all of the ice and send all of that carbon dioxide into the atmosphere. Let me ask you, is that a good idea? Do we think that dropping atomic bombs on the North and South Pole of another planet is going to make it really livable?
Maybe not if we want to live there. Maybe like way, way, way in the future, it could bounce back. But I'm guessing that there's other options, other solutions we could probably find.
I would hope so. That's the thing with changing the entire environment of a planet. There's lots of ideas of ways that you could. It's more difficult to think of realistic ways, I think. Now, like we talked about, the problems with the atmosphere being stripped away, putting greenhouse gases in it won't really help because they get blown away too. Well, what if we could stop the atmosphere from being blown away? Now, here on Earth, our atmosphere gets to stay intact because we have this amazing magnetic field that surrounds our whole planet, and it protects us from that solar wind. It hits that magnetic field and then passes over, so we get to keep our atmosphere. But Mars doesn't have that. It doesn't have much of a magnetic field, definitely not a big, robust one like we do. So what if we could do something to make sort of a shield to protect Mars from that solar wind? That's another idea that people have thought of, is using something called a magnetic shield. They basically just want to take a gigantic magnet and put it out in space, kind of close to Mars, but at a strategic point where that solar wind would hit the magnet, and instead of moving straight on, it would kind of blow up and over and miss Mars entirely. So you can see Mars there on the screen is kind of in the wake behind this magnetic shield. Now, this is not an unrealistic idea. This is a pretty cool idea, I think. The only problem is we have to think of how expensive it would be to not only create the technology, make something big enough to shield an entire planet, and then we'd have to maintain it as well. What happens when it breaks? What if it gets hit by some space debris? What if it gets knocked out of orbit and ends up somewhere entirely different? And then there's a giant magnet floating around in space. These are all things that we have to think about when we're talking about making huge dynamic changes to an entire environment. And there's tons and tons of other ideas of ways that we could terraform Mars. I'm interested to know if any of you have heard of any really interesting ways of terraforming Mars or any other planet, or if you have any ideas of ways that we could adjust either the atmosphere, the temperature, the soil, anything that would change the environment. Give us a chat and let us know, because I always like to hear these fun theories.
The more creative, the better, honestly. Sometimes you need to think way outside the box to come up with a good solution to things.
Absolutely. And while you're thinking about that and while you're responding, I'm going to keep moving because we have to talk a little bit more about some of these issues and things we have to think about when we're talking about terraforming an entire planet, because it's not just logistical things always that we have to think about. There are other questions that we have to ask too. One of the big things that we have to think about when we're changing the environment of an entire planet is the timescales. These things, these kind of changes that we need to make could take millions of years to go into effect. Just like it took millions of years from Mars to go from a relatively warm, watery place that might have been good for life to this barren, frozen desert that we see now. That transition took millions of years. So to go back the other way would probably also take millions of years. Is that a time commitment that we are willing to make? Again, we talked about the resources. All of these things that we want to do are going to be very, very expensive. Is this a monetary investment that we're willing to make? Are we willing to put a ton of money into changing an entire other planet when we have plenty of other things here on Earth that need fixing too? So it's very much a balance there. There's all sorts of unforeseen consequences that we could run into. Changing the environment just in one place could change something entirely different. Think about ecosystems here on Earth. If we change one part of an ecosystem, how does that affect the rest of the system? These things are very, very complex, and making one small change can make huge changes elsewhere. So we really have to keep that in mind too. And then the last big one that we always think about are the ethical considerations, which is a whole category of questions that we could ask. Do we have the right to change another planet? What if there's already some sort of life there that we don't know about, that we just don't recognize? Could we accidentally destroy an entire life form just to benefit us? Who's in charge of this terraforming? Is this going to be done by the United States, the United Nations, spacefaring nations? What about all the countries that don't have space programs? Do they have a say? Does everyone get to participate? And then people always point out we're really bad at managing our own environment. What makes us think that we're going to be any good with the environment of another planet? All sorts of things. Can you guys think of any other questions? Sort of these ethical quandaries that you have to go into? I'm sure there's tons of them.
Mm-hmm.
It all kind of comes back to what we call Dr. Malcolm's principle. Is when people get so preoccupied with whether or not they could, they don't stop to think if they should. That sort of encapsulates all of these ethical considerations that we have to think about. And I know that's been a bit kind of doom and gloom and kind of sad and, not really fun to think about all these things that could go wrong. But at the end, I want to bring it back to our people, because people always, why, if it's so terrible and it's so hard, why do we even want to send people there to begin with? There are great reasons to send people to Mars. It's not just all super complicated. It is super complicated, but there's plenty of things that people can do that robots can't. There's only so much that we can learn from robots and spacecraft, which is tons. We've learned so much about Mars just with telescopes and spacecraft and rovers, but people can help us learn even more. Can you guys think of some things that people can do that robots couldn't? I have a couple that I know. Maybe you could chat us some ideas there too, if you have any. One of the big things that I think about right off the bat is that people are really good at moving around. Robots, not so much. So people can get out, we can walk around, we can climb up hills and mountains or down into valleys and ravines. Let's take a look at the Martian landscape and see what it looks like on the surface. We've got some really great, cool shots we can show you here.
Yeah, as we zoom on in there, it might take a little bit for some of these maps to load up for us, but we'll get there. And why don't we show you some images in the meantime? There they come.
So these are pictures actually taken by robots on the surface of Mars. So this is what Mars looks like on its surface. And you can see there's all sorts of really amazing mountains and cliffs and cool stuff to climb on. I love climbing on things. So that's super exciting to me to be able to look at that. But robots have a really hard time climbing mountains, climbing up cliffs. This is not something that they do easily. In fact, we can show you a little video of one of the rovers for Mars that's being tested to drive on the surface. Ooh, another great Martian landscape picture. Again, look at all that sand and dust and cliffs. So this video shows us a rover built by the European Space Agency to go to Mars. Look at him there. He's super cute. But look at him driving. Look how hard it has to work to get over that one tiny little pebble.
Very slowly. Gotta be
very
careful.
Slow.
You don't want anything to break when it's that far away from home.
Exactly. It's so far away. All of those instruments that it's carrying are very sensitive. We can't shake them around too much. And then it's also got to look around. It can't look and process and walk at the same time. So it has to stop and look around, and then it'll move a little bit and stop and look around. It's not efficient. It's not an efficient way to travel. And Mars, like you can see in my background and in Jeremy's, it's very rocky. There's huge boulders everywhere. So a little robot like this is going to have a really hard time just moving around. And because of that, they also move very, very slowly. If we look at Perseverance and the track that it's going to be taking from Jezero crater, it's going to come out of the crater and kind of poke around in what we call the ejecta blanket, this area that's right around the crater. It's got a little path that it's going to follow to get there. You can see there that orange line shows us the path that Perseverance is going to be taking. That whole path is about 12 miles, and it's going to take Perseverance about a year to go 12 miles. I don't know if any of you guys like to hike. I like to hike, and I've hiked 12 miles in like 6 hours. Definitely not a whole year. So it's a very, very long time. They're very slow. Robots are just not good at getting around. Now, we've also talked a little bit a second ago about what happens if it breaks. Robots are also not very good at fixing themselves. There was the InSight lander, which is still on Mars, had a little drill tool on it. That was its big thing. We were excited about having this drill. And the drill broke, and it took over a year to get it fixed. That's a really long time when you really want your studies and your scientific data. To have a whole year where you don't have an instrument that's working. So people would be able to fix things much, much quicker. Even ourselves, we fix each other faster than that. People can also respond quickly to unexpected information. You know, a robot has to be mostly pre-programmed, especially being on Mars. It's a really long way to Mars, and it's basically the communication between Earth and Mars is kind of like satellite internet. It's not very fast. It can take up to 20 minutes just to get a message to Mars one way, and then another 20 minutes to get back. And who knows what that little rover has done in those 40 minutes. It could be, you know, a little ways down the road, and then you got to tell it to stop and come back and all of this. So people don't have to worry about that. If I was walking along one way and say, oh, there's something really interesting over there, I can just go walk over there and check it out. I don't have to wait 40 minutes for a message. So these are some things that we're really good at, especially with Perseverance. One of its main missions is to examine what they call compelling rocks, which I think is a fun thought, that a rock is so compelling. But how does it know? How does Perseverance know what a compelling rock is? Like these ones you see here, I think those are super compelling. But does Perseverance as a robot know that that's an interesting rock that I want to look at? It doesn't know what I want to look at. And again, I would want to go up and look at it and touch it and climb it. But these formations you see here are 500 feet tall. So I don't imagine our little rover that's moving very, very slowly and very carefully getting too close to these and really getting us a good idea of what's going on here. So there's tons and tons and tons of things that people can do that robots can't. And that's the big reason why we want to send people to Mars or to other planets. And with that, that is just about our time for today. I know that was a whole lot of information, so we definitely wanted to leave time here at the end for questions. If you have any questions about people on Mars, living on Mars, terraforming Mars, or anything about Mars really, or space in general, we're happy to answer any of your questions or anything that you've thought about through this. If you've been watching our whole series, if you've come for any of these, we're happy to take your questions.
Yeah, feel free to drop those questions in the chat. Yeah, we're excited to answer them for you.
Yeah.
As we're panning around here inside Jezero crater, where Perseverance is going to be landing in about, what, month, 2 months?
2 months.
Almost 2 months. Wow. Time flies.
Getting close. It's exciting. These are really cool pictures.
Yeah, so the reason why some of this stuff is taking a little bit longer to load is everything we've been showing you on the dome side are all actual data maps that have been created. So we're using a program called OpenSpace, which you could check out as well. You just type in openspaceproject.com and you could go check it out, and maybe you could do it as well. But it's very, very cool software that allows you to look real in close to the surface of all these different planets. And we've just been focusing on Mars, but in future Dome to Home series, I know we'll be going all over the solar system and universe. So
yeah. And just for reference, we're at the bottom of the crater, and the sides of the crater are what look like mountains right there. Those are just a little bit taller than the Flatirons. So this is very similar to if you were, down in Boulder and looking up at the mountains. It's about what you would see from 𝐀𝐜𝐭𝐢𝐸 crater, which I think is pretty cool.
All right, any questions? Let's see, anything rolling in here?
Nothing yet.
Hopefully we make it to Mars sometime soon. I'm thinking probably a good 10 to 15 years minimum, I would say, but what do you think, Tara?
I think minimum, yeah.
Yeah.
I think it's gonna be quite a while before we can get there, even with just the idea of building habitats for us and making it, even small scale livable. I know a lot of people are really excited for us to try these sorts of things on the moon first. Because it's a lot closer, it's easier to get to. If something goes wrong, we're only 2 days away instead of months away.
Mm-hmm.
And so they're testing a lot of this on the moon. And especially since they're getting ready to send people back to the moon in, 2 years? 2022, 2024, we're going to be sending people to the moon. So that'll be a good test of how we can make, livable habitats and things, how we can spend long periods of time on other planets, which I think is super exciting.
Let's see. Any other questions? Anything anybody just been dying to ask us? Doesn't have to be about Mars. Could be about life. Anything out there.
We're happy to talk about just about anything.
Just about anything. Yeah, that's right. We'll see. But if not, I'll have to sign off then sometime here in a little bit. Anything else that you wanted to show about Perseverance to Mars, Tara? Anything we maybe forgot to show? Maybe anything we would just be remiss if we forgot to show?
I think in 12 weeks we have pretty much covered everything about Perseverance.
I think so.
I can't think of anything that we
haven't
been able to explain just yet.
Yeah. I know a lot about the mission now, which is awesome. I'm super excited. I can't wait to watch the landing.
Yeah.
Ooh, that's one thing. Make sure below us should be a link. It's in last week's video as well. You can check out the link to watch the landing live on February 18th. As it's crashing through the atmosphere and hopefully land safely in 𝐀𝐜𝐭𝐢𝐸 crater. That will be awesome. I can't wait for that.
Yeah, if you didn't get to see our video last week about how Perseverance is going to land with the sky crane and jets and things, you should definitely check that out because it's super interesting to see how we're actually going to put this thing down on the planet safely. That's the hard thing to do.
Yeah.
Well, if we don't have any more questions coming through, if you think of any that you want to ask later on, or maybe you just didn't get in time, go ahead and drop those in the comments and we'll come back and answer those questions for you. Jeremy's keeping an eye on things. Normally I would say come back next week, but don't come back next week because we're not going to be here. Again, this is our last one of this series. So definitely keep an eye on our website, though, www.colorado.edu/Fiske. That's going to be our homepage, and that's going to be your place to find all of the information when we start learning more about what our topics are going to be for next season. We're going to start back up in the spring, but we'll post the official start date on there as well. Topics, you can ask questions from the website, all sorts of cool things. For teachers and parents, if you'd like to help us keep Dome to Home going and donate to the planetarium, there's also an option on our webpage to do that as well. Oh, did we have a question? I think we had a question come. What does Mars's atmosphere look like? That is an excellent question. So actually, if you look at the dome view here that Jeremy's showing us, that's pretty much what Mars's atmosphere looks like. It's very sort of yellowy, reddish, because there's so much dust in the air. All of the red and orangish yellow dirt that's all over Mars, that gets kicked up into the air and makes the sky look this really weird yellowy color. Also, all of the carbon dioxide in the atmosphere can scatter the light and make it look that yellowy color. So it's kind of the opposite of here on Earth, where we have blue skies during the day and red sunsets. Mars has reddish yellow skies during the day and blue sunsets, which is pretty cool. So you can see these pictures. That's exactly what Mars's atmosphere looks like. That's an excellent question.
Oops, there's another one. Good, kind of a image of it as well. Yeah. Kind of that haze.
Not quite as yellowy.
Yeah.
It does get a really crazy dust storms on Mars. That dust can kick up and it'll cover the entire planet. And that's probably a very yellowy red sky. Pictures from Curiosity seem to show it as pink. Why is that? It's going to be the same reasons. It's that dust that gets kicked up into the atmosphere. That dust is very red. And so when the sunlight hits it, it's going to make the sky look really red. Same kind of things that we get pink sunsets here on Earth because of the way that sunlight is scattered when it hits different molecules, different dust particles and combinations and things. That's a lot of why it's going to be that kind of pinkish color. So Mars is just generally red everywhere you look. The ground, the sky, everything's very reddish, orangish. Blue at sunset, that is correct. If you see pictures of Mars's sunsets, you can sometimes look these up from pictures from Curiosity, especially. It has pictures of the sunsets where the sky looks very blue, which is super interesting. And again, that just goes back to the way that the sunlight is hitting the atmosphere and the different compounds and particles and things in the atmosphere are scattering the light. They scatter it different ways depending on what's in the atmosphere. So when it's very long and very low in the sky, it's going to make that look a lot bluer. Yeah, kind of like Jeremy's is.
Yeah, let's see. I'm going to see real quick in the last second if I can simulate a little sunset for us on Gale Crater. Maybe slow it down a little bit. We're going through day. Or Gale Crater. Geez, Jezero Crater. Oh my goodness.
Gale Crater is where Curiosity is. Let's see. What about sunrise?
Oops.
I believe that sunrise is the same. Yeah.
I zipped right past it. Oh no. Let me rewind time a little bit.
Uh-oh.
We'll see that bluish color come back. The stars are moving the wrong direction in the sky. There we go. Right there.
Yeah, look at that. How cool is that?
I think that might be a great way to end this series. A little sunset in Jezero Crater. What do you think, Tara?
I think that's a perfect way to call it a day and a month and a series. So thank you again all for joining us. Yeah, if you have more questions, drop them in the comments there. We'll get back to you. Thank you for coming and learning with us. Again, these videos are available on YouTube forever. So if there's any you missed, or if you want to go back and watch some of the older ones, they're still there for you. Be sure to like, comment, share with your friends and family and teachers and whoever you like. And hopefully we will see you again in January.
That's right.
So until then, have a wonderful holiday season, and we hope to see you again.
Thank you so much, everybody. Take care. Be safe.